Howdy again, it's tubalcain, Mr. P222, and here I am at the Bridgeport mill, all coffeeed up in my basement. It's the middle of January, there's 6 inches of snow out, and I'm homebound. Well, I'm having fun down here anyway, but the title of this video is, and it may be more than one, is Comparing Accuracies on the Bridgeport mill. Now, I recently made a couple of videos, and they were entitled, I'll put the numbers on the screen here. Now, I was rather surprised at the interest in that because I thought, well, nobody's going to watch those videos because what little interest would they have. But again, it is incredibly difficult to space holes accurately. I mean within 1/1000th of an inch or so. And if you've done any work in a shop at all, you know what I'm talking about. But I don't want to talk about that so much as immediately in the responses, and read the comments, they're always real interesting. But somebody said, well, how do you know how accurate your digital readout is? Well, you know, I had never given that a thought, and I thought, well, all digital readouts, and here's the glass scale, have the accuracy built into them. And when it's a Bosch & Lomb scale, and this is, yeah, this is Bosch & Lomb, I thought, you know, that was a premier name. That's got to be perfect to within 1/2,000. But there are tolerances on here, on these things, and I understand that many makers make them to the 1/10th of 1,000th, but this is to the 1/2 of 1,000th. But I'm going to try to prove to you how accurate it is, and I'm going to compare that with 3 other methods. So one being the digital readout on a 6-inch caliper, and Mitutoyo dial indicator, and let's see, one other method. Well, oh, and the dials themselves on the Bridgeport mill. So I think this is going to be fun, and it might run into more than one video, so stick with me. All right, here's my setup, and it's a bit nightmarish, and it's like a Frankenlab, you know, to quote Ask Jerry. But I have 3 different methods here, actually 4. And I was going to incorporate even several more, but I ran out of room here and out of energy. But again, I'm going to reiterate here that I am comparing here the accurate digital readout with the dials, which really means the screws and nuts of the Bridgeport itself. And then also, and you're going to laugh at this, here is my Schar's, and you'll get better views of this, calipers, and that's all set up and clamped in place. And then also back here there is a magnetic base for an indicator, and there is the Mitutoyo dial indicator. I know something's out of focus here because of all of the other things in the way here, but that is an indicator that will go read up to 2 inches. Now, sorry for you guys in Europe, but this is strictly imperial because I do not have the capabilities here with the dials and all of that to do metric, but I think you'll like this. I intended to also compare with gauge blocks, and I may carry that one step farther, but there just was no room in here. There's just no room left to do that, and that requires a little extra work. And also I wanted to play around with Vernier scales. Well, this is the only Vernier scale that I have. Everything else that was Vernier I got rid of. I'm going to have to level with you. I hate Vernier scales. You know, they were and are a nightmare, and they're obsolete now with all of the digital and electronic gear that we have. I don't want to argue about that. Now, this, of course, is a Bridgeport mill, but when I was a young man on my first job at Osborne Engineering, we had 2, count them, 2 Index brand milling machines. Later it became Index Wells. I don't know what it is now, if it's even around. But there was no digital readout, so right here on the front, and then also down here, there were Vernier scales. So in other words, there was a long scale like this, with pointers and everything, and that's how I learned accuracy. But it was very, very subject to human error reading these little scales. And even back then, I used a flashlight and a magnifying glass, and I still got that magnifying glass I bought for that purpose. So I'm explaining here different ways of working accurately. Now on a jig borer, and look up some images on that if you do not know what I'm talking about in terms of a jig borer. But they used a system here of trays and rods and indicators, and they were incredibly accurate, but that's all been replaced now with the digital readout. So those were some of the different methods. So all right, enough of that historical talk. Let's zero in here and do some actual experimenting. And this is an experiment, and yes, I know I lack the scientific method, for those of you that know what that is. So, all right, on with it here. All right, let's look at the setup here now. The vise is clamped securely so it can't move. The Schar's caliper is clamped here to the vise, and I know I'm going to get criticized for that, but there is a piece of lead there to protect it. Well, now I'm going to get reamed on using lead. So, you know, you can't win with some of the critics. You just can't win. All right, in the collet here now, this is a piece of 1/2-inch rod, so it's pretty stiff. Pretty rigid, but somebody's going to say you should have used 1.5 inches. So I know people are going to pick this apart, but for all intents and purposes, this will do. And let me illustrate. The purpose of this close-up is just to show that there could be some flexing of this 1/2-inch bar. Now I have to exert quite a bit of pressure to do that, but that's what somebody's going to say, is that's flexing. But I don't think it'll flex just with the pressure of the pointer here, or the jaw. Actually, this is one of the jaws on the Schar's calipers. Let me make a comment here. I still have people that are calling these Vernier calipers. They are not Vernier calipers. They're not the dial calipers. That's a digital caliper or an electronic caliper or whatever other term you want. But Vernier refers to a Vernier scale. This is a Vernier scale. A Vernier scale can be used on scores and scores of different instruments, some that aren't even measuring instruments. So that's a type of scale invented by the great Frenchman. I think his name was Pierre Vernier. Maybe I got his first name wrong. I'm thinking of Pierre's Garage. So anyway, that is how the caliper is set up. And that will only work in one direction. Then I have to bring it back and zero it out. But that is one part of the measurement system. And then, of course, I'm using the machine dials here, graduated dials. But really, this is just a readout for the screws and the brass nuts in there. So I guess it's not a brass nut, it's a cast iron nut. But this machine, again, came from a school. And even though it's probably about 50 years old, it probably does not have that many hours on it. Maybe it's got 1,000 hours, but it's not been used day in and day out. So I will be watching this graduated dial here. I may not always zero in on that each time, but I will read this as carefully as I can with good light and my magnifiers. And granted, this digital readout and Sebastian Lam Accurate 2 is also, it's probably 40 years old now. This one reads within 1/2 of a thousandth. The little 5 there is half. So I will be watching this as well. All 4 of these measurements will be taken simultaneously. And finally here, number 4, we got a magnetic base attached onto the column here, and then this 2-inch travel Mitutoyo dial indicator touching the end right here. That's where the pointer is. And then, of course, there is the dial. So in review, I will remove the backlash by backing it up 2 full turns and then engaging it in, setting this for 0, setting the dial indicator for 0, setting this for 0, and the digital readout up there at 0. And then I will start to move the table. The backlash has been removed, and I'm very carefully setting the graduated dial at 0 and locking it. Next, no big deal here, I don't know why I'm showing this, zeroing out the x-axis, I don't care about the y. And I have zeroed out the caliper. Notice that the tiny little 0 there is a 1/2 thousandth. And finally, the dial caliper is up against the stop here. And I've carefully set it so I have 2 inches of travel, because there really isn't any extra travel there on this indicator. And we consider Mitutoyo high end, don't we? I think we do. And I do. And we'll set that for 0. Not quite. Remember, we got a little parallax error there, if you know what that is. So I will reset this looking straight on, because you can't look at it at an angle or you get an error. I'm trying to be accurate. Now, I'm not going to lie to you. I experimented with this. I spent yesterday afternoon, when I should have been watching football games with my wife. Well, I'll use the magnifier, and if I can find my flashlight, I'll use a flashlight, but I'm going to advance it, remember, ultimately 2 inches. But I think I'll start by moving it 500 thousandths. Remember that these Bridgeport dials are 200 thousandths per revolution, so 500 thousandths, and then we'll take a reading on all 4 of the instruments. Here we go. 200, 400, I can never overshoot it, or I will have backlash and I will have to start over. Does everyone understand that? I know you do, or you wouldn't be watching this. Alright, let's take a reading here. The digital readout reads exactly 500 thousandths. The caliper reads 1/2 thousandth less than 500 thousandths. And the Mitutoyo looks like it's about 3/4 of a thousandth off. Now I will advance to 1 inch. But is it surprising that the dial is exactly the same as the digital readout? Alright, I'm moving it to 1 inch. Okay, let's look at some instruments here. That is at 1 inch, as close as I can possibly get it with the human eye. And the DRO reads 1/2 thousandth off. The caliper reads exactly 1 inch. And the Mitutoyo is a full thousandth off. Quite interesting so far, is it not? And now I'll crank it in to 1.5 inches. Alright, let's look at some instruments here. And the digital readout is 1 full thousandth off. The caliper is a 1/2 thousandth off. Or is it the screw that's off? And the dial indicator is 1.5 thousandths off. I'm a little surprised at that. In review now, there are two electronic methods here. The caliper and the DRO is strictly electronic with scales, and the dial indicator is strictly mechanical, as is the crank along with the nut and the screw. Old technology, Archimedes. And last, and probably least, I'm going to crank it to 2 inches. The DRO is reading 1/1000th off, but I actually would think that this is the standard. This is accurate, and probably 1/1000th error in the screw, but again, I'm deducing all of that. The Schar's caliper is 1/2 thousandth different from the Bosch & Lomb. There could be some error that I introduced in some other way there, because I'm surprised there's even 1/2 thousandth off. And surprising enough, the indicator is off almost 2 thousandths, just a little less. I am surprised at that. I enjoyed doing that, and I hope you enjoyed watching it. Now I'm going to approach this just a little bit different as I conclude this video. And in some ways, just the opposite. That is, I'm going to use the digital readout here as the standard. Now, you won't see me doing it, but I'm going to crank, and I'm going to be watching this, and I'm going to move it exactly 2 inches, 2.000, on the DRO, and then we'll go back and look at the other 3 readings. So I'm doing it just backwards. I tend to think this is the most accurate instrument in the whole setup here. That's my thesis. All right, here we go. And I may speed some of this up to cut the boredom. 2 inches. Everything's been zeroed out. There. Took me a long time to creep up on that. Now I'll move the camera in and we'll take some other readings. Now, if you look at the graduated dial there, I'm exactly 1/1000th off. That shouldn't surprise anyone that there would be some error, maybe even in a brand new screw, let alone the screw and the nut of a 50-year-old machine. The caliper shows 2 inches and then 1/2 thousand, so it's 1/2 thousandths difference. Now let's take a look at the Mitutoyo, and it's only 1/1000th off. So you can see the readings are a little different when I do everything backwards according to the hallmark, really, which is the digital readout. Now for some of us, a 64th or even an 1/8 of an inch is good enough, isn't it? Depending on the job. But everything that I have just shown you pales in comparison to the accuracy of Joe blocks, gauge blocks, in this case Dual brand. And there's a 2-incher and a 1-incher. And really I would like to do a setup using those, but I'm not sure I can work that accurately on a setup on this machine to use those. And I would like to do a follow-up video using a Vernier scale and a couple others. I don't know if I will. That remains to be seen. Depends on how many people enjoyed this or comment on it or find interest in it. If you like something like this, give me a thumbs up. Subscribe, if you will. did you enjoy watching this as much as I did doing it? You know, I've never done anything like this in my life, and I would have to say this is probably a YouTube first, probably because there's no demand for it. But it was fun comparing, and really all of them are pretty accurate. The only thing that surprised me is that there was a minor inaccuracy in a dial indicator, but when you think about all the little moving parts in there and the gears and the little rack in there, that, you know, I suppose there's plenty of room for error, and that probably within the tolerance of that instrument when it was made. Or is that instrument worn out? It really hasn't had much use. It's not an old beat up thing that came from a factory. In fact, I bought that, I believe, at a garage sale in the box some time ago, and I thought maybe it had received no use at all. So thanks for watching, and I will see you, or should I say you will see me, in my next video. So long for now.